There, hopefully audio is working. We're getting some cool looks here. There.
Oh yeah, I forgot to test that it actually.
I know, you have to fiddle around.
Signals,
Oh yeah.
Using the long channels and all that. Yep.
All right. There. Is that everything? It might be.
So I'm hearing Greg. He usually wants to start with some words.
Oh yeah, yep. That's why I switched to the.
Hey, Mark.
Hello. Okay, let's get to this guy. We're going to go back to.
All right. Hope everybody's had a good week and has survived all the going-ons. When Susie comes in later, or probably at the end of the meeting, we'll thank Susie for her generosity this morning in feeding us and hydrating us, or dehydrating us for us to normally drink coffee. She didn't realize she could do this.
There he is.
Quite close to a year, and when Susie was here and they did it, she's like, "Wait, I can bring food. You can always bring food if you want, but there's no pressure." So she wanted to do that. She runs a consulting firm, or a HR company that hires people. So if you're looking for work or want to talk, specifically Red Hat is one of our customers. So feel free, if you know anybody who may be looking or are looking, to point them to Susan. I will let people know there's a DevOps Northern Virginia that started. It's either February or March. And their meeting is this Tuesday at 6:30 at the team office in Reston, which are Hunter Mill Road and Sunrise Valley, which is the south side of the toll road. If you pay attention on toll road and you see the sign that says Walmart Data Center or Walmart Technology Center or something like that, it's right in that neck of the woods. What's the name of the company? OTEMO. OTEEMO. They're on Meetup. So if you go to Meetup and you look up Nova DevOps, you'll find it. The address of the OTEMO is 10701 Park Ridge Boulevard.
He's just testing.
Yeah, I'm just checking to make sure the audio is working.
So they're that's the next meetup, and there's been a lot. I don't know. I know John talked about Slack. I think that's 2 months ago, and someone had mentioned DC Tech. So from a technology point of view, sort of keeping up with some of the stuff going on in tech is a pretty good Slack. I don't even know what they call the Slack team. Slack team. That's right. Team and then channels. I was going to say the superset of channels. So team is a pretty good one to get on if you're interested. And you should be able to find it. If you can't find it, you feel free to hit me up on Greg, and I'm happy to send you a link.
And you can let me know as well.
And John Kennedy can help you also. So there's Susie's in here now, so we can all thank Susie for our dehydration and
thank you.
Carbohydrates in the morning. Does anybody else have any announcements or anything they'd like to share before we get started? No.
Icon.
What about it?
It's going to happen pretty soon. I think it's like this weekend, then next weekend. So they have a lot of live feeds. So
Okay. So yeah, share the stuff with PyCon so that for those who may be interested.
Yes, next weekend.
Next weekend.
Yeah.
So it competes with the Reston Fine Arts Festival, which is at the Evil Town Center, where they will be having free parking for the weekend, but you can never park during Fine Arts Festival anyway. For those who don't know, actually Reston Fine Arts Festival I think is the largest on the East Coast. It's actually pretty good if you're if you like all sorts of different types of art, just hanging out. Now, the other interesting thing is the weather. It has about a 65% chance of being crappy the weekend of Fine Arts Festival. So last year it was rained out, and performed, and so last year she was not able to perform. She's hoping that this year they will perform. But it's actually a pretty good event, just walking around and seeing a lot of the different art. And they've now started to up it a little bit by having live performances and whatnot going on. So it is a nice thing, and you can support the restaurants and other businesses there without paying Boston property at that time also. So, not that I have a very strong opinion about it. Anything else? As
Icon here, or is it West Coast or where?
It's in Seattle,
Yeah.
but it's between May 17th and 23rd, and they have a lot of live.
Yeah.
Okay.
There's some interesting talk.
Yeah, maybe we should start a channel on the NOVALug Slack. We can keep stuff up so that people are, if there's an interesting talk, we can promote it there so that people know. I'll let Susie, you want to say anything about the positions you're hiring for?
Thank you. I'm here on behalf of Red Hat. So we have an invitational that we're going to be interviewing not only platform engineers, but middleware engineers for those of you who may be interested, not as Linux users definitely may be interested, but we're open to all types of systems engineers. So that will be coming up on May 23rd. So if you're interested, please connect with me and I'll give you more information.
And that's, so I think I saw something about it. It sounds like it's pretty interesting instead of the standard. So I worked at Red Hat, ran interviews at Red Hat, and was pretty involved with some of the changes during the process. And this is like, you know, a speed dating interview type thing, right? Is that?
I wouldn't call it that exactly.
But that's a good analogy.
Okay, so what we do is we have you come in, we sort of provide you with information about Red Hat, their benefits, what a day in the life, if you will, sort of like a half-hour presentation, and then you do a technical interview for 45-minute technical interview with a hiring manager and someone who would be a technical peer. So you knock out like 3 stages of the interview process and nothing else.
Oh, for some reason.
Speed dating, yes, but it's 45-minute interview.
So
So that's not to be speed dating.
for some reason, I thought it was like 3 or 4 different people that you spoke with, like 15 to a half hour each. But no, okay, so I misread it
You
wrong.
meet 3 people at the same time and
Got it.
45 minutes together.
Okay.
Fun times.
Yeah. And so it was interesting. I was talking to someone this week who was thinking of changing career or changing roles, and you know, I said, you know, what do you want to do? Do you have any sort of updated resume, something? Because you know, your LinkedIn basically lists, you know, the jobs you've had, no information. So I have no idea what you like, what you do, anything. Yeah, I should really update my resume. It's been 4.5 years, and I said, I understand it's really hard, but you know, just pick a day, and once a year you update it. I said, like your birthday, anything. He's like, oh yeah, I was thinking the first of the year, which I'd never do. It's like, no, pick a day, another significant day that you'll remember, right? And then that just should be the day that you update your resume. That way it's not, you know, the type of thing where you have to go back and figure out what you've done over the last decade or whatever. So just as a tidbit. The other thing, you know, I interviewed someone yesterday, and they came in sort of like, yeah, we got a cold call. It sounded interesting. You know, we're not necessarily really looking. Well, the best time to find a good job is when you're not looking. And I said, the other thing is, I was talking to a coworker. We're like, yeah, I mean, if someone calls us and there's an interesting opportunity, even if we're not looking, you go and talk to the person, because it's always good practice to make sure you know how to interview. And to have that experience, just like I tell people, getting up here and talking, you know, unlike, you know, Doug, who's afraid to talk in front of people, you know, to get up and to do it, it's good practice. So, you know, with the opportunity to interview, if it's in your field and something that you're interested in, you never know what may be out there. So I always recommend people to the listen, as I say, the #1 hobby in Washington DC area is looking for your next job. So, and then there are some people that you talk to and they say they're not interested, and then you hear like a month later they took a new job, and then you're saying, what's up with that? I've had 2 or 3 people that recently, over the last 2 months, where that happened. So, the other thing is, between Slack, between the user group, between the meetups, always a good resource just sort of to reach out. And, sometimes there's people willing to listen and to be a sounding board. So don't be afraid to use your networking. So with that, Doug had given an introductory talk on Docker and containers a couple months back. And we had talked about that time giving sort of a follow-up, more of a hands-on. And so I do see some laptops out there, which is good for people who want to follow on. But it's an opportunity for you to dive a little deeper. Next month, Xavier is going to be talking DNS, right? Mm-hmm. And so some of the stuff that around that, there was, I guess we were talking about TLS at work this week. And, it was like, it's one of the things that's very important people need to do, but no one can get it right? No one remembers everything. You always have to go look it up. It's one of those things. DNS is sort of one of those other similar things, right? If you're running your own bind server, the 2 things you remember, you put a dot after the TLD, and you update the serial by at least 1. So if you remember those 2 things, chances are that's going to solve 90% of your problems with DNS if you're configuring your own bind server. I don't know enough about the other services out there to know. Gandhi and Route 53, which is what's in AWS, are a lot more forgiving and easier to maintain. But I look forward to learning more about that at our meeting in June. I don't think we have a topic for July yet, so if anybody has any ideas, want to speak up, let us know, and be happy. Before you leave, if you can just come up and make sure that you just put a scribble by your name, or if not, put person A or whatever at the bottom of the list and scratch by the name. It's more about just a head count. It's not to track anybody or anything like that. So, it could say, White House Correspondent 1 and through N, or White House Correspondent 1 50 times on the page with marks, and that counts. So if you can just make sure, you just try to keep it count. So I appreciate it. So with that, Doug, any other introductions you would like me to make or something to say about you?
No, your point on TLS is a good one. It is something that is a pain, and somebody's got to do it type stuff. I mean, it's very interesting. We were just having a discussion recently about that, and that is do terminate SSL at the ELB, at the load balancer, or all the way to the application. That kind of stuff is non-trivial and yet necessary. I hate that stuff. It's hard.
So I look forward to a talk by the end of the year. Thank you.
That's not going to be from me. I like for it to work easy, because I've never understood it well enough to trust myself to be relied on to architect that.
Well, if you want to find people, if this is the topic, I can certainly find people that will be willing to sort of speak about it.
No, it'd be great to have someone come in and talk a little bit about TLS, and if they can talk a little bit about, how they would set it up, in an Azure or an AWS, or through a proxy, Nginx, whatever, from that endpoint would be absolutely interesting. Because I think, especially with some of the changes going on, talking about security and encryption are becoming more and more important, and to understand what's going on from an end user, even at a high level, I think is important. I think people are getting to the point where they now realize, and I got something the other day from DHS, they want to do an interview. I have a global global entry, and they're looking at the next level. So people may have seen this week 2 announcements that came out. One, that they're looking at banning all laptops, all devices on international flights into the US now. I don't think that's going to happen, because it was supposed to happen on Thursday, and there was an Iowa when that came out. I can't see that happening, or if there is, there will definitely be a way to pay that you'll be able to bring your laptop on, because there's way too many business people traveling.
Yeah, that was carried on, and you had to check it.
Right, yeah, there's no way you're gonna be on the plane for 7 hours without your laptop flying between Europe and the US. Too many business people get way too much work done, so I don't see that happening. And then the other one was about the face recognition. So, about when you're walking through, what they want to do is when you're walking through the airport, specifically when you're coming back from from out of country, that they'll be able to recognize and they'll be able to fast track people through, so you won't have to stand in line. So if you've ever had to go through customs coming back, it can be a very long process. So they want to, they have some ideas, and they're looking for people to come and try this out. And they're going to pay $25 an hour for roughly a 4-hour block over in, I think it's in Landover, where they're going to want you to walk through these systems so they can check it out and whatnot. So I don't know if I've been approved yet or not. But it came through, and it looked a little hinky, because I just heard something about the other day. And I'm like, oh, this is one of these, it's someone trying to capture something. And I saw the little lock. I'm like, okay. So I clicked on the lock and went through the whole chain to make sure that, yes, in fact, it was a DHS website that it pointed me to, and that all of it was valid. So I think people are starting to become more aware when they get emails or they go to websites to check to make sure that these websites are who they say they are before they add or enter any information. And so that all goes back to the TLS, which goes back to the initial conversation where Doug got me sidetracked. So Doug, I'm going to turn back over to you now.
All righty. I'm going to stand here for a minute, and we're going to switch back to the presentation on the thing. So the subject of Docker comes up regularly. Obviously, there's a lot going on nowadays with it. It's evolving a whole lot. A number of vendors that are working in that area, a number of cloud providers. There's a bunch of tooling being developed, all them things. It's evolving at a pace that is hard to believe for something that's existed in containers. This is Docker anyway, 4 years. 4 years to last month, in fact. So the evolution of it is profound in terms of how this has happened. So we had a talk, as Greg said a couple of months ago, on kind of an intro to Docker, where it was, you can use Docker whether you're a developer or not. You don't have to be a developer to use it. There are some things you need to know to do that, and that's what we went over in that presentation. It primarily was, how can you run stuff as containers and rather than installing them on your machine? And that was really the focus of that presentation. It was being able to take tooling that's out there right now that you, in the past, would have had to install, and then potentially install dependencies, and then potentially upgrade later or mess around with, reconfigure, that kind of stuff. The alternative is to run them as containers in a Docker type environment and not have to go through that installation process. So it's a maintenance or upgrade or management process down the line, and there's some real benefits to that. There are some caveats to it as well. It's not necessarily, I won't say it's difficult, but it's not always just 5 minutes type thing. You do have to have some familiarity. It's not a whole lot. So as an extension to that, kind of the next step is, if you want to make your own stuff, how do you do that? And building images are the way that you can do it. So what I have is a presentation that is on that subject, and it covers a variety of areas, including security. In fact, that's one of the things toward the end that we're going to talk about for a little bit. So we're going to bounce around a little bit in the presentation because I'm doing it in a different way than what I've done in the past. There's a tool out there, or a framework, or whatever you want to call it, called Reveal.js, that will render stuff in browsers, basically. So in the past, I've done stuff with PowerPoint, and then with Keynote, and then with PDFs, and then even with Evernote, in fact, in presentations. And all of them have drawbacks, but the advantages. But this time I thought I'd try it this way to see how it goes. It's a different way of doing presentations. So it involves some interpretive dance. So we'll see how well that goes. So I'm going to switch to that, and we'll start looking at some slides, and we'll actually do some stuff, actually. So let's do it like this, rather than doing the whole desktop. We'll see if this works. I don't know if it will or not. I don't know. So we're going to switch to this guy. Now, what you should be seeing, hopefully in the stream, is this big old slide right here. And we're going to be talking about building your own images. Now, there's a big discussion in this area, and we'll talk about that for a little bit. Oh, let me explain, by the way. What you're looking at right now is called GitPitch, Gitpich. And what this does is if you have a repo at GitHub, or I think Bitbucket, or maybe somewhere else as well, it's in Markdown. If you go to GitPitch and give it your repo URL, it will load that Markdown and render it in Reveal. Now, what that means is this right here. See this little guy right here, this little arrow? Go click, and we can go. I'm going to flip around a little bit and then go back to where we are, but you click, click, click. Notice there's a down button that just lit up. Blah, 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 blah. So what I'm doing is, rather than the presentation with slides just being sequential or linear, instead, there's horizontal and vertical scrolling in it. So horizontal are your major topics in slides, and then the vertical arrowing down are your subtopics. That's what GitPitch is doing, is it's taking your Markdown and turning it into that. So that has some advantages, although right now I'm drawing a blank on what they are. It has some disadvantages, one of which is it changes the way you do presentations. And when you start doing it, it's funny, because if you think of things just being slide, 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 that's relatively straightforward. When you think of it as slide, subslide, 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 slide, subslide, it does change the way you think and the way you do stuff. So that's what you're going to be looking at today, and I'm not very good at it, and you'll see some evidence of that in this. So,
quick question.
Yep.
Can you show, so I know you brought up markup, and we had a side conversation that we should probably have a talk in the future about markup. Can you just show what markup looks like, just in a
Markdown.
Or Markdown.
Markdown, although Markdown is markup, oddly enough. If you want to go back, if you're as old as Greg, and Greg is pretty old, you'd probably be familiar with NROF and TROF and LaTeX and all them other ROFs and LEX out there. It is interesting. It's a fascinating subject. And what Markdown looks like is this. We'll actually go to the repo. This guy right here. There. So this is example. This is actually a GitHub repo of mine with the presentation in it. And in it, there's this file called pitchme.md. That is what pitchme looks for, or GitPitch looks for, that is. So there. What it actually looks like is this. So here I'm going to show it to you this way first, then switch to the raw view, which is actually the content. So this is what Markdown looks like from the perspective of not being rendered, meaning you're just looking at it using GitHub's Markdown viewing. Let's go to the raw, this guy right here. And picture in your mind something you probably can't see for squat. There, let's do this. There. So Markdown is text with embedded special characters or recognized characters that tell who's ever displaying the Markdown what to do with it. So for example, 3 dashes mean new page. So this is saying, this is the first slide, next page, agenda, 2 hashtags are a heading, so this means heading level 2. Asterisk or dash or maybe something else means unnumbered list, bullet list, basically. Okay, and that's really all it is. Now notice, instead of 3 dashes, there are 3 pluses. That tells GitPitch to go down, to put down arrows in. So the next slides that are delineated by the plus signs mean down, 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 down. The next time you see a 3 dashes, it means move right. Right or left. That's what I'm trying to say. I don't know how to say it any better than that, but so they're just simple characters. And then there's a couple of other things to know about, like where they be. Oh, we're getting there. I'm telling you. There. These 3 guys right here. 3 back quotes. 3 single back quotes. That means embedded text block type thing. So take the formatting and don't reformat it and try and flow the lines or anything along that line. So Markdown, when you get to text, like paragraphs, reflow so that sentences will come together and have spacers and all that stuff. That's all Markdown is. There's really nothing more than that. And there's other characters that I'm not using in it, but when it boils down to it, that's what it actually looks like. So again, in GitHub will recognize Markdown and do it, but it won't know what you mean by pluses and minuses. That's an extension of it that GitPitch is doing. Alrighty. So any questions on Markdown? It's popular if you're old like Greg, not me certainly. When I mentioned nroff and troff a way back, what you had to do was you had text files or files that had embedded stuff in them, and then you ran a post processor on that or a processor on it that actually produced whatever it is out, whatever kind of output that you wanted. Man pages are that way, in fact. So then publishing systems came around and big old sophisticated things that came up that had embedded characters, and you actually saw a WYSIWYG type view on the thing. And now we're kind of heading back down to the Markdown view because it's a lesser, it's less overhead, less tooling involved, stuff like that. And there's some advantages, some significant advantages. One of which is when you have things like PowerPoint, try to stick those into a configuration manager repository and track changes in them. That'll drive you insane. But with text files, you can still do that, and it makes life quite a bit better if you're managing your stuff in the configuration management systems, such as Git repos, for example, or CVS or whatever. So that's the reason that kind of stuff exists. All right. So the kind of things we're going to talk about today are what is this Docker thing? And note I've got a little d in here. You're going to see big D Docker and little d Docker sometimes. Then we'll talk a little bit about that. Some things you need to know associated with building images, and what are images, or I should say things you need to know in general, not just associated with images, but what are images, where can you find and store images, how can you do things, some links at the end. So some of this stuff we're going to do interactively, and some you can give it a try yourself. Now, so what I was saying earlier is, in our previous presentation, we were talking about Docker for everybody, meaning how could you do it without having to be a developer? It did mean you needed to have it installed wherever you were running it, for example, but you didn't necessarily have to fiddle around with images and Docker files and all them other things yourself. So what I did was I went out in various places and cut and pasted text to do some explanation in this, and I thought I'd show a little bit about that. But the key thing on this is that you can also make your own Docker images. You can make things, or you make your own images. I shouldn't just say use the term Docker, because they can be just called images or container images or whatever. But you can create your own that has your own stuff in it. Now, with the things we're going to talk about today, there's nothing that keeps you from installing it yourself. Right now, what I'm doing is on the Mac, I'm running this guy right here, 1705 Community Edition, up in the AWS. Up. Maybe. I'm running 1705 to E2, so I never got how about that. So,
Can you increase the font?
oh,
See it?
good golly. Let's do that. Let's make that a little bit bigger. Generally, I remember to do that. I didn't this time.
Okay.
There. So again, what I'm doing up there, I decided to do it up there so that not only we can do it up in on Linux versus on the Mac, in fact, and there won't be a whole lot of difference, but I thought it'd be fun to do.
So quick question, just out of interest.
Yeah.
So I'm running the same version of Docker, but I'm running 181 of Go. I'm wondering why I'm running a different version of Go.
I don't know. Who knows? This is another aspect of layering of stuff. So I installed this. So you did not install Go independently?
Not knowingly.
Huh, that's interesting.
Yeah, no, I did not do it independently.
That's interesting. Yeah, I don't know, but to answer your question, I do not have a clue. But
And so just as another thing, I love to talk on Go.
Yep.
So
Go is a fascinating subject. I've got several friends that are working in it and love it. It's like everything else. With sometimes you can get very parochial about stuff. I think that one guy has a company that does Go stuff for embedded type environments, and those static binaries are particularly advantageous. There are some aspects of that work well. And the Go types that are doing development all seem to be real excited about it. So, but yes, if there's Go people in here, you would certainly benefit folks to do that. Have a presentation on it. All right, now. Where do you get this here Docker thing? There are a variety of ways to do this. Some are more confusing than others. Now, you can get it right from docker.com itself, Community Edition, this guy. By the way, here's one drawback by the Git pitch. Git pitch, or in Chrome that is, notice this page is in Norwegian. I don't know, it doesn't look like it to me, but who knows, I don't speak Norwegian. So Chrome thinks that the Git pitch Markdown is Norwegian for some reason. I have no idea why that is, but it does, and does it every time I get there. So anyway, One of the other aspects are links. With GitPitch, the way it's built in, if you can put hrefs in it or link references in it, but it will do it inline in the page itself. So click on this link with it using just plain old Markdown, and it'll bring the page up in this tab, and you have to back arrow on it. So, or you're gonna do this, aren't you? So I have a bad link there. I did that link wrong. I did that link wrong. Let's keep going. Here we go. Anyway, subsequent links are going to be better. There, I swear we're getting there. Okay, so anyway, you can get it from this guy. Install it there. Now, the other way you can get it is, this is confusing. One of the things that came up is Docker is learning the experience of Kleenex, and that is, hey, my product name is my company name. And down the line, that will bite you. That will bite you, no question about it. Never do that. So the Moby project was created, and Docker is open sourcing some of the layers or the components associated with Docker, or they have been. I shouldn't say Docker. It's a community type thing. So originally, Docker was an engine. It was CLI and an engine, one big thing, monolithic. It was broke out into pieces, became easier to maintain. The pieces there are container management, et cetera, stuff like that. The Moby project is the open sourcing of that. Now, I fiddled around with this a couple times, gave up. So what I wanted to do was I wanted to go solely community just to see how well it worked. By solely community, I mean built myself. I had trouble with it, and I just couldn't figure it out, and I didn't have time to mess with it. What I've been doing the last few weeks has been log aggregation related, and that's a big subject that has occupied my attention for quite a while, and I haven't been able to get back to Moby worth it. But you certainly can give it a try and see what happens. You're going to find this most likely easier in the near term. So now, things to note. It's interesting, by the way. Here's one of the things to note about the GitPitch and reveal, that is. So notice when I left and right arrow, and I know this is a side note, but I've noticed this recently. Where I last was is where I still am at. Meaning, if I'm trying to get to the top of this major slide every time, I may need to go back up again to get to the top of that slide. That's just another little caveat about reveal. So I cut and pasted this from Wikipedia or something like this, and then the last section I actually got from a podcast, a Cloudcast, I think it was, or one of the podcasts the other day. That was a particularly good one where they just had a Docker in a nutshell: sandbox application, secure an environment. The section above that, or the big old long thing, is more of a Wikipedia or somebody's description of it, what Docker actually is. I'm going to assume everybody's at least somewhat familiar with it, meaning that I want to take an application, rather than installing the binary, and run it inside something else, inside a container. That's really all that it boils down to. There's a whole lot more detail on that out there in the world. Now, some of the bigger picture associated with it, microservices. One of the things that you'll tend to find in container applications is, rather than having a big old monolithic war file or Java class or whatever, instead it will tend to be little boogers, little things that are out there that all talk to each other. That tends to be what Docker looks like. The effect of that will tend to be you'll be running a lot of containers on your machine. You most likely will. Well, rather than running a single tool, single container type thing, it's not unusual to have a number of them that are an application or subsystem or service or whatever. The other thing is clusters. So having one container or one engine running containers is one thing, but you most likely are going to want a bigger environment. You're going to have quite a bit of capacity sitting out there. So this would be in a situation, a cluster or cloud type case, where you want to be able to run multiple containers, same type. You want to be able to scale them, individual layers of your services, that kind of stuff, come and go. You're going to see various providers that are out there doing that, various means of doing that. In the case of clustering, there are different approaches to do it. There's the Docker Swarm, which was one of the original approaches to how clustering done. Then Kubernetes came around that had Google's approach to container orchestration and clustering. And then OpenShift built on top of that, and they added a significant amount of code associated with how clustering is done in that environment, clustering and orchestration. You can also run it exclusively in the cloud. And this is something I've been on the edge of experimenting with, in terms of, I've been considering getting a thin client type thing, a Chromebook, and running exclusively in the cloud, just to see how well that works versus a machine. I have significantly less compute resources at home than I used to, but I still have an expensive laptop. It'd be interesting to try something else. But from the perspective of Docker and containers, You can run them in Red Hat's OpenShift. You can run it in the AWS in their own ECS environment, which is Elastic Container Service or something like that. I forget what it's called. Azure has a container environment. Google has one, certainly. So there are different ways that you can run containers, or you can run them entirely locally. In most cases, you're probably going to want you'll probably want to run them locally, but you certainly don't have to. One of the other things to be aware of is when you start looking at these kind of things, now you have multiple things that are doing stuff for you. Docker engines, for example, Containerd, all the other bits and pieces. All of them are generating log files, or most of them are potentially generating log files. And this is just from the perspective of some of the experiences I've had in the last so many months. And that is where in the past you've had one application. Say in the old days you used to run a program, and whatever that program said, that's everything that you needed to know if you're debugging or you wanted awareness. Then it went to application servers like Tomcat, JBoss, etc., that kind of stuff. Now you've got both your stuff generating log output, and you got that next level up of the application server, whatever it is, and it may be generating log output that you want to know. And it gets more and more complicated as time goes on. So logging and log aggregation gets surprisingly challenging or more of interest in a container environment, because you may want to know what the cluster stuff is saying if you want to have awareness of your system, or you may want to know what your applications are saying, or you may want them all aggregated in a single system, in a single log aggregation system. So that does not have to do with the images that we're talking about, the kind of stuff we're talking about today, but it's something to be aware of, that when you start using it for real, that there's a whole lot of data out there that you probably want to have coalesced into a single place. Because let's say you've got a cluster running, you've got 3 nodes running, for example, and you've got containers, X number of containers running all, and those containers are coming in, potentially are coming and going, meaning it might run on this node once, it might run on some other node some other time, it might run on another one. How are you going to know what those log files are saying from the thing? So up front, when you start planning these kind of architectures where you're using containers, you need to think about how you're going to take log and event type data from that cluster and get it to a single accessible spot. Otherwise, you're going to be SSHing all over the place, for example, or you're going to be doing Docker logs all over the place, which is surprisingly aggravating. So, and can hide a lot of problems and other concerns and so on. So anyway, log aggregation is another area of a container environment that becomes more critical, I think, than in the past. And lastly, security. And obviously, we were talking about that earlier. But this gets particularly important, where you can run containers in a way that opens you up to all kinds of abuse. So it's amazing how that is easy to do, and that by accident. So it's the sort of thing where you do need to have some awareness of. And on top of that, this is another area that I tend to find that you have to pay attention to, and that is that you haven't, or I have not heard about this yet, but I have yet to hear of malicious images sitting out in Docker Hub, for example, and I'll explain more about that later on. But I also see a surprising number of repos that are sitting out there that have no information about them, no documentation, no provenance, no nothing or whatever. So the subject of container or image security, content trust is the term I'm looking for, gets even more important. So for example, with these kind of tools, you could write some software and push it out there on Docker Hub, and it could be the greatest thing in the world. And how does somebody else know you produced that? How do they know you put out an update to it? How do they know that somebody else didn't have some kind of malicious intent and replace your image? So you're going to hear the term content trust every now and then. So if you're making images and those images are being distributed to somebody else, you may want to consider what's necessary to sign those images in a way that somebody else that you have non-repudiation, or whatever the right term is, that somebody else knows you actually produced this, you actually are maintaining it, or have put the updates out there, or that you haven't, your cert hasn't expired, or whatever. So anyway, there's a variety of things in this area that get way more complicated than we're going to talk about, but I wanted to mention them in this just so you begin to see some of those terms. The kind of commands that you're going to need to do if you're going to be building images or using stuff in general. I had notification turns off. We're going to keep seeing some of this stuff up here on. So the kind of commands you're going to need to do, I'm going to show several of them right here, and there's a number of them. But if you're running the client and you do Docker help, for example, you're going to see a boatload of subcommands that didn't used to exist, actually. So for example, let's say Docker help. All these things are possible now. Way back when, 2 years ago or 3 years ago, it was quite a bit less than this, but quite a bit fewer of them. But now there's more, and there's continuing to be more. There's also changed the CLI in terms of the structure of it, where now you're going to see subcommands like Docker image, Docker container, Docker something, and then a command after that. So we'll see. There we go. There's the words I'm looking for right there, management commands. So for example, now there's a second layer that's been added to the command structure that it's useful to be aware of. That I don't think you have to use it, but it begins to be a good idea to do those things, because they were just getting to be too many different unrelated functions all sitting at the same hierarchical level. Now, Docker version, what am I running? And that's the thing that Greg noted a moment ago. And it's interesting that he sees a different Go build than I do, in fact, on the way I installed it. But it may have to do with the way that I installed this. It's entirely possible that again, I'm talking EC2 right now. Actually, no, that's interesting that you say that. Give me a second, and I will. No, even locally, so I still show 1.7. I don't know why you have 1.8, Greg. That's interesting. So help version info. Those are going to be the kind of things that tell you something about your container environment. Now, if you want to run something, here are the sorts of commands that you're going to most likely have to make use of at some point. One is Docker run. I want to run something. PS. What's running? What did I run in the past? What's still sitting in my container cache, for example? Docker exec is another one that's useful. And we talked a little bit about that in the first presentation, I think, where something's running and I want to jump into it. I want to run in. The typical case will be I want to run a shell in a container that's sitting out there already, that's running already. So Docker exec is how you do that, and that's a useful thing to know because it helps you debug some of your problems. So, for example, you could be building images and something ain't working right, and you wonder what in the world's going on. Docker logs may tell you something about it. The other thing is you can Docker exec a shell right into that container and look around and see what is different about this image than I thought would be there. What doesn't make any sense. So associated with images, there are the image commands themselves. Docker images will tell you what images have I pulled, built, etc. So for example, let's flip out of here. Let's go. You know what occurs to me? I'll bet I am not sharing the terminal, which means the stream is not seeing what I'm doing right now. Going. All right, give me a second. That's another aspect of this that's different. All right, let's do this. Let's share the desktop. All right, now. That may or may not be doing the right thing. I don't know. So it's possible that the viewers are not seeing squat right now. So, but anyway, the key thing is images will tell you what's been pulled. So let's do this. Let's say Docker images, right? Let's say Docker images -A. Hey, in EC2 right now, I've only got a couple of things that I've messed with so far. Let's take a look at locally. I'm going to bump that in a moment. So take a look at the stuff that I've been running, and you'll see quite a bit more things that are sitting in my image cache. This is another thing to be cognizant of when you're building images of your own. And that is, how big are they? How much stuff are you creating without necessarily being aware of it? So like these big old numbers out here, 1.5 gigabyte, 1.15 gigabytes, X 100 megabytes, et cetera, and then down to little things like 51 megabytes. So size of images will matter to you at some point. And we'll talk about that as well. And we'll actually try a couple of things just so you can see what it's going to look like when you try some of these. Build is how you're going to actually make some. Yep.
Is the cache only local, or you can also have access to something remotely?
So now that's a good question. And that is, the reason that's a good question is local and remote. When you type the Docker command, you're running a CLI. That CLI can be talking to an engine running on your machine, or it could be talking to an engine running somewhere else, or it could actually be talking to a manager in front of a cluster running somewhere else. So the cache that you're looking at are whatever your client is talking to. So the image cache could be remote, or it could be local, depending on who you're configured to talk to. And the way you do that is the Docker host environment variable, or arguments for that matter. So it is easy to forget what you're talking to. In fact, and on occasion, I've done that where I've been connected to a remote engine and forgotten, and then start doing commands that I think are local and get some confusing results or change something that I didn't actually mean to. So, and this goes into the area of protections, where because it's a client-server type situation where there's a CLI configured something else, you have to make sure that in your production environment, you don't have operations guys accidentally doing one thing when they think they're doing something else, or developers that are connected to a production environment. So security and protections become important in those areas in a container environment or in any client-server environment. It's just you run the risk of some confusion as to where stuff is. Another thing that you'll hear the term every now and then is DIND, Docker in Docker. Docker in Docker. What that means is you can run a container that in a way that container has Docker in it, the Docker CLI in it, for example. And it can be completely independent, be its own Docker environment with its image cache, or in the DIND case, you can run it in a way so the client is connected to the socket on the host's Docker engine, so it's using that host image cache. So it's another bit of area that can lead to some confusion. And DIND is particularly popular because it lets people Dockerize Docker stuff, and you Docker all over the place. You just recruit yourself to no end when you're talking about it and get to some confusion. But it's a big thing because it does mean that you can take advantage of Docker in containers and use that image cache that's already sitting on your host, and it's going to be way more efficient time-wise. So, for example, if you have a Docker and Docker container that you run, if you pull a hello world on your host and it's in its image cache, and then you go running a Docker container that does a hello world, do you want it to pull it again, or why not just use that image cache on the host? So anyway, I know that's a whole lot more detail than you were interested in, but the whole point being that because it's client server, the way that you're configured, that cache could be local, it could be remote, it could be actually inside a container all by itself on your host. Right? Now, build. So, custom image of some kind, or else I just want to reproduce an image that's already sitting out there. We're going to see a little bit more on how to do that. Lastly, I want that image to go somewhere. So when you build an image using a Docker file or whatever, that image is local. I'm using the term local. It is whatever your client is configured to talk. So that image could actually be somewhere else. Now, this is an aspect of the build command to be aware of. And I just realized I want to put some more notes in these, and I didn't. And that is, when you do a build, the CLI isn't doing the build. Meaning that little client that you're running isn't actually doing the build. Instead, what's happening is it's packaging up your stuff, and I'll explain stuff in a minute, and sending that to the engine that it's talking to. The engine that it's talking to is what is actually doing the build, and then storing in its own cache. So when I say that, the reason that that's important is in pretty much every piece of documentation you ever see, or tutorial or example, it will say, if you're going to make a new Docker image, if you're going to create a Docker file, create a directory and put it in there. Docker file in your home directory, for example. And I think I mentioned this in the previous session. And that is that if you put, when you say Docker build, dot, for example, the most common thing you'll see, Docker build dot, and that means dot in the current directory, use the Docker file in it. It will say, okay, I'm going to get whatever's in dot and everything under that and open up a connection to the engine and push that whole shebang to it as a big old tarball, basically, and the engine will get all that stuff. One, it may not need it, and two, you may not want your private files or whatever being sent to the Docker engine and potentially being logged at a debug log level by the engine somewhere, captured by a log aggregation system, showing up in the log aggregation system, and have all your little stuff sitting out there accessible to somebody else somewhere. So there are aspects of things like this that matter to you when you start doing this kind of stuff that it's worthwhile to be aware of. All right, if you want to look around, meaning the kind of commands that you'll most likely use are the logs command and the inspect command. Logs will get you the logs being generated by containers. You can actually go a level above that, go to the engines and so on, but it's logs of stuff that's running right now in real time potentially, or whatever the last so many lines of the log being generated was, or logs of something that has been run in the past and has not been removed yet. So logging is that aspect I keep coming back to. It affects a number of things, and this is one of the areas that's useful to be aware of. So inspect means I want to go get the metadata associated with some resource in my system. Docker inspect a container, Docker inspect an image, a volume, a network, a whatever else I can't think of right now. So you can get back a lot of metadata sitting out there. So for example, let's do this. And I'm not positive what's in the stream right now. I hope that this is showing up. It occurs to me that
It is.
it is. Good.
It's a little hard to read, but it is showing up.
Okay. All right, so for example, let's do this. Let's say Docker PS. So I've got an Nginx running in there right now. Just for fun, I'm going to say Docker inspects this guy right here. And I'll talk over it a little bit to tell it. But so inspect is going to give you information about that container that's running. And needless to say, if you like information, you're just going to love this type of thing, because there's no lack of information sitting out there. You don't need to be aware of exactly details, but the point I was trying to make is the kind of commands that you're going to use when you start building images are going to be things like building and running images, I should say, of images of your own. Logs is going to tell you something about it. Inspect is going to tell you something about it. That is just useful to know those two things out there. Here's a caveat on using inspect. So I could have said, I could have run a container and give it a name. I could have run an Alpine Linux and called it Ubuntu if I wanted to. And then I could have said Docker inspects Ubuntu. So what was I inspecting? Just something to be aware of, that there's a caveat. There's not a caveat, that's not the word I'm trying to use. I think this is the syntax. Let's see. Yep, that's not what it is. I don't know. Anyway, there's some syntax that says, I want to inspect a container with this name. And its syntax is something close to this, but this isn't right. If you just do inspect using names, that name is arbitrary. It could be whatever it wants to be. This was something that we had a lesson learned some time ago that I had an experience on with some automation where we didn't realize that multiple things could have the same name. So you could have a volume called something, a container called something, an image called something, and a network something, all called the same thing. And when you do an inspect, it will simply get the first one that shows in the map that it gets back again, which could be random. It could be any one of them, and your post-processing might get caught by surprise because it gets a different inspect than you think. So there is such a thing called Docker inspect. That's the point I'm trying to make. Yes?
Sorry, another question.
Huh?
All those information, they are stored somewhere as metadata, or it's coming straight from the running case?
I don't know entirely. I know that they're stored somewhere. Now,
Okay.
Which part are you talking about?
yeah, it depends on what the
So
thing is you're talking about.
For instance, there was the MAC address, there was the IP address,
Yeah.
the container that you were inspecting. So is that something that comes straight from the system as is running right now, or is it something that stores on the side?
when you have a container instance, remember there's an image and there's an instance.
Okay.
When you create an instance, those values are retrieved once and kept. As long as that instance exists, it's kind of like DHCP, then that MAC address, that IP address is reserved for that instance as long as it exists, even if it's not one.
Okay.
And that's a little file in your file system somewhere that hides for you, but everything is a little file somewhere.
Okay.
The image information, there's data that is in your image, and there's metadata about that image too. In essence, your image is a top level. So there's a small JSON file, I think it is, that contains all the metadata about it, and then it points to the actual files with the data, the binary data that you need. And the hard part here is to understand that images is layered. So you say you have one set of images, and then your copying file on top of that. So you might have some blocks in one image and another block in another image. It gets kind of complicated eventually. But it's all stored, so when you're running things, and that's important, the machine that runs your container has all of that metadata locally. If it's not there, it has to download it.
Yep.
And when it comes to runtime, it's up to the runtime engine to determine, well, I need to give you an IP address. No, I need to give you an MAC address. Oh, I need to give you some other ID that is randomly generated when you start it out, like a UID. You show them all the funny names that containers get.
Yeah. So by the way, the syntax is this: -- type blank and then the thing. just so you know.
So all that is stored. Basically, that should be more or less the straight format you can get from the file. It might be formatted nicely here, but that's it. But, and I think we already heard it, like, this is ephemeral. Do not put this data inside your container, ever, never, because they will change. When you run your container tomorrow, it may mean an updated image, and guess that old image you had is gone, wiped out. You get a new IP address, or everything. So this is just ephemeral stuff. It's really only needed by the person looking at the whole host with all the containers. If you're running your container itself, meaning your Tomcat app or Node.js, whatever else you're running, that information comes from your OS, whatever you want to call it, and that's where you need to retrieve it from. You do not retrieve it from here.
Yep, it's a good idea to get it in real time. That's the main thing. So the whole point being, logs and inspect tell you stuff about what's going on, right? The kind of things that you might do for maintenance, meaning I've got containers that I've run that have exited. They're still sitting in cache out there. I can remove those. I can remove the writable layer anyway. I want to remove images sitting in my class. Lastly, something that's shown up in the last so many versions of the Docker subsystem or system is the prune command. You can say, prune, I want to clean up some stuff. Do a Docker prune, it'll come back and say, what do you want to, remove everything, something along those lines. So that's another aspect of, because there's caching going on, that caching is growing potentially, meaning that on your host, wherever your engines are running, I should say, they have an image cache on them that stuff is coming and going out of and growing over time. At some point, you're probably going to want to have to maintain that, because eventually everything fills up and will catch you by surprise when it does. And it can be pretty aggravating when that happens. So those are kind of the sort of the primary commands you'll use most of the time, but there are 40 other ones beyond these, obviously, that once you start building and running images, you'll most likely have to get a little more familiar with, because you're probably going to have bugs. I mean, when you start building an image, you run the risk of inducing problems. Whenever little fingers start hitting keyboards, boy, you're just asking for that finger bone to make a typo and cause some confusion. So that debugging techniques will become more of interest to you. So here's another term I heard that was on one of the podcasts the other day, images, binary blobs. That's an interesting point, actually. I think that it's a good description. Another one is this big old long paragraph right here that I'm going to read just because I like reading it. So an image is inert, immutable file, essentially a snapshot of a container. I wouldn't say it's a snapshot of a container. I kind of view it the other way. A container is a snapshot of an image. I kind of view that in a different direction than what they said in this. But when you do a build using some input file, that could be a Docker file or a file called Docker file, it will take that, from that it'll figure out what it is you want to go in this container, this image, and how it's going to be configured, and then produce an image that will most likely be composed of one or more layers, each of which will have its own stuff in it, its own goodies in it. And then when you run that image, it will instantiate that into memory, just in a crudely being said. Now, once you have that image, you got it locally, everything worked just fine. But if you want somebody else to use that image, you got to stick it somewhere that somebody else can get to it. And that would be a repository or registry. So the common one that you'll hear is Docker Hub. I've got a number of them listed later on just to show you some of the other ones that are out there that are worthwhile to be aware of. But it's something else to consider. If you're going to start building your own images, and you want to give them to somebody else, you got to have a place to put those things. And there's a variety of choices as to how you're going to do it, the architecture you're going to run in. Images can get pretty big. Those images may have a bunch of layers in them. And so something I always recommend to do if you want to get an appreciation of it, and we'll see a little bit how to do this, is when you start building images, every now and then it's worthwhile to export those out to a tarball and explode that tarball and just look inside physically to see what's in there, because it's just kind of interesting. You'll learn more. You'll see where metadata is stored. You'll see the fact that it's composed of layers. Each of the layers are tarballs of their own, or can be.
The command that shows you the whole tree of all the images.
Absolutely, yep. It is very interesting to do that. It gives you an appreciation of the detail of that's happening in it. And lastly, minimal amount of data being sent when transferring images. This is why images are composed of layers. And what I mean by that is when you start building something, you can use techniques that will cause you to build a 1 gigabyte file that has one layer in it And every time somebody does a pull of that the first time, that 1 gigabyte will come down there. Even if that 1 gigabyte has a ton of common stuff in it, like CentOS commands or data files or something like that, you can configure images or construct. Yep.
Someone's trying to watch the stream, they would love the camera to have a better angle, because right now it's showing something weird and it's very.
Oh, they can't.
As
Oh,
of the
crap!
camera.
They can't see the slides. Dang gummit! This is not working very well, is it? Okay. All right. I think we're going to switch back to the slide view on the Hangout. Sorry about that. I did not realize. I was kind of dumb with it. There. Let's go back. All right. We'll go back to this guy. I'm going to flip back a couple of slides just so folks can see it. I'm going to show you what the slides were I was just on a moment ago. Sorry about that. That is no good way to see this. So I'm going to put back up here. We'll show the commands really quickly again. The kind of stuff that I was talking about a minute ago: help version info, run ps exec. So images that are in my cache, how to build, how to push, stick them somewhere else, logs and inspect. Maintenance, the kind of things that you'll end up having to do once you start building images. If you got a CI system that's building an image every 5 seconds, at some point you're going to run out of space somewhere. You're most likely going to want to clean up. You'll have to maintain your image cache. So what are images? So this is the comment I was making a while ago about what images physically are, and coming down to the size aspect of it. So images are structured as layers for a reason. The reason is, once each of those layers gets pulled into your image cache, subsequent image pulls that have the same layers in them don't need to pull the same layers again. It's an efficiency perspective, both from the aspect of making images smaller, as small as you can, and with as many common elements in them as you can. If you make 2 applications and they both share 95% of the utilities, they need to be done, and you can structure them in a way so that your users aren't always having to pull a whole bunch of stuff for both of the applications. I'm not saying that very well, but the point being, the layers are independently in the cache. Each of those layers can be used on subsequent run commands or pull commands if they're the same as the layer that you want to get. I know I'm definitely not saying that in a clear fashion, but we can talk more about that. Let's keep on going a bit. So now, typically, the way you're going to build in the simplest case, and that is with a Docker file. Docker file is a text file that has in it the stuff you want to go into the image and the way you want it to be configured and the way you want it to get run. We're going to see some examples of that. I've got a couple of links down here that are good ones to go to just for fun. Let's see if my link works. There we go. So it did pop up another tab. That's what I was trying to do first time. This here link right here will take you to what can actually go in a Docker file, and it is a lot of stuff, needless to say, and that's grown over time. So go down here a ways. You can see the sort of stuff that's in it. I'm going to mention some specifics in a moment, but all of this stuff is associated with Docker files, or can be associated with them. All right, now let's go back and look at my examples. I do recommend this guy right here, by the way, Dockerfile Best Practices. So this is a good one to look at because they explain some of the reasons that the size of your layers matters, that the organization of your layers matter. Every time you do a build, it's a good idea to have those layers, your add and copy, etc. commands structured in a way that it doesn't reproduce stuff that is the same as it was last time. And I'm not going to try to explain that right now, but it has to do with the efficiency of what's going in the image itself. So the sort of commands that you're going to see and the ones you're probably going to use the most are the next couple of slides. The from command. That's the starting point of a Docker file, meaning what do I want to start with? If I'm going to run some utility, is that utility found in CentOS? Is it found in Ubuntu? Is it found in a Perl build? And so that from command will not always be an operating system, or distribution is a better term for it. It will not always be that. It may be something else entirely. That something else might there in its Docker file might have come from a distribution. So anyway, key thing is this: the from command you're going to see most of the time. It'll be one that you'll probably start with. It will become of interest to you as to whether you're going to say from Ubuntu or from Alpine. And the difference is this. Big distributions like Ubuntu will have hundreds of megabytes, 250 megabytes or something along that line of stuff. Alpine will have anywhere from 5 to 43 megabytes of stuff. It will tend to be smaller. So the from command will matter to you in terms of both what you need and how efficient it is of what you're building. The run command is in the Docker file, and it says, I want you to run something. You'll see some examples in a moment. Then there's copy and add. Take something from the host or outside the environment and include it in the image. Copy means copy from the host. Add can mean copy from the host. It can also be a URL. It can also be a variety of things, I think. Go get something from somewhere else and package it in this image. So that's the distinction between copy and add. I think the best practice is actually say don't use add. They say use copy because it's just confusing to kind of have an overloaded command like add that has a whole bunch of stuff in it. I don't know if I agree with that or not, but it's just to be aware of there's a distinction between copy and add, where add will do what copy does and more. Work tier. Where do I want the stuff that I'm doing to go in the image that I'm building? So that's one set of commands that you'll most likely use most of the time or see as a reference when you look in a Docker file. Some other ones. The entry point command. When I run a container from this image, do I want something to run right out of the box without the user having to know that it's doing or know anything that's happening? Example that we'll look at with the lenticular, the Perl script that I did. That's an example. There's no reason the user who's running this thing needs to know what it's actually running. He's simply saying, run a container from this image, and I want it to do what it's supposed to do. So entry point is a way to indicate that. Command within a Docker file lets you set default arguments for what's going to get run so that the user, once again, doesn't necessarily have to do them. He can replace them with something else, but the idea is that it may reduce the amount of knowledge your users of your images have to know. Mess with environment variables, obviously typical thing. Expose, this gets particularly useful as well. Depending on the type of images that you're building, you may be building an image that sits on a network socket or sits on a network port or whatever. If so, it has to pick a port. It has to know what it is that it's listening to, for example. If you use the expose command inside the Docker file, you can tell the engine that's running this that this application needs port 80 or port 8080 or whatever it is available to the outside world when this gets run, so that the person running it doesn't necessarily know the specifics of that. So that's another command anyway that you'll get. Now it may be you'll never use the expose command. It's possible that you're building images that have tools in them. Perl scripts, applications, Go binaries, whatever it is, they don't do anything on the network. All they do is operate on the local file system, for example, or they don't present any service to the outside world, but they go connect to Google or they connect to something else. If that's the situation, you most likely would not use expose at all, very likely. Now, label has started showed up some time ago, and this got particularly useful because it began to let you include metadata within the images that are being built. Because you can build images that have all sorts of stuff in them that nobody knows about, don't have any provenance, they don't have your name or anything like that. Or you can begin to include that sort of information using the label the label keyword and have a bunch of metadata that describes what it is that you're building. It may have even some other stuff beyond that. So I just wanted to pass along a few of the commands you would the few of the Docker file commands that you would most likely be getting familiar with or be using. Big note right here. If you see from Ubuntu, CentOS, Alpine, it doesn't mean it's taking that whole operating system and sticking inside your image. That isn't what is actually happening. It's simply saying, from that distribution, I want some stuff. Okay, and it may be that there are different functions that are in different distributions, but the key thing is this: you're not running. If you do from Ubuntu, it doesn't mean run Ubuntu on top of my machine. That isn't what is actually happening physically. It simply means some of the stuff that you're getting stuff from that distribution image and including it in yours. Some utility tool, whatever it is, data, etc. Another useful thing to be aware of: the expose command thing I mentioned earlier that was port related. Okay, what that does is it tells the engine, the thing that's running it, containerd, whatever it is, that this application, this service needs this port. If the user, when they're doing the Docker run command, says -P, for example, that means map whatever ports I need that are indicated by the image to whatever host ports you want, and the engine will do that all by itself. So, and I know that may make no sense to you at all, but the key thing is this. The expose command is a way to pass along a little more information to the containerd or engine or whatever that's running this image that it needs to manage this application and present a service to the outside world. Right? So what a Docker file might look like is this guy. This is my little lenticular script that I always use as an example, just because I understand it. That's really the main thing. But this is what you might see in a Docker file. Once again, from Alpine, meaning start with the Alpine distribution. There's something in that distribution that I wanted to make use of. Notice the next thing, this is label maintainer. So that used to be a keyword called maintainer, I think it was, but that was all it was. It was just that one keyword, maintainer, and then email address or some kind of information. And then somebody realized there really wasn't a need for a specific keyword. Instead, treat it as a label. The reason that that's in there means that that little bit of metadata goes into the image so that somebody doing an inspect can actually see, go give me the labels that are inside this image. One of those labels is maintainer, and this is who it is that's maintaining the thing. So whenever you start making your own images, your own Docker files or whatever, it's a good idea to include contact information. How does somebody know how to get back to it? They might find this to be the greatest thing in the world, or else they might have a suggestion or whatever on things that could be done to enhance it. Including this kind of information is useful. Notice this next thing. This guy right here, label, org.label, schema, VCS, URL. Where did the source for this Docker file and anything else that it's using come from? This is a standard scheme that lets that get contained within the image itself. Description. So this is another thing. If you go looking around on Docker Hub, for example, at images, you'll be surprised how many images out there that don't have any descriptive information in them at all. You don't know what in the world this thing's talking about. You can use the label field, and again, the standard schema description, namespace, whatever you want to call it, that has at least some information to say, what is this thing? What do it do? Now, next thing, copy command. So this is the simplest example, one of the simplest examples of how to build images of your own. This comes back to that prior presentation where I had a Perl script that I had around for a long time that would combine two images and create a third image with the slots or the slices interlaced between them. So what I wanted to do was Dockerize it. And the way that I did it was, all it was saying, take an Alpine distribution, copy my script into the temp directory in that distribution, or the image, I should say, that I'm producing right now. I'm going to make the work dir temp, which means it'll do everything in temp from that point on within the Docker file. I want to do an Alpine update, meaning bring the distribution up to date. I want to add the Perl command utility service, whatever you want to call it, to that distribution, and then Perl GD, which is graphics something or other. I forget what that stands for. And then lastly, when this script gets run, the entry point I want is run the script. So this is a really trivial example of building your own image. This is all that's required to do it. So from this, in fact, you could actually do this yourself, meaning you should be able to do a clone or whatever of this repo. You should end up with a Docker file and this in it, and be able to do a Docker build, and it will create an image. And that's an example of, that's the simplest example of something that you can come up with. So I know what I just said is a whole lot of stuff, and it's not going to make sense in a lot of cases. Any questions before we go any further? I know it's hard to ask questions about something that is so broad sometimes, but if you have questions, sing out anytime, and don't feel bad about it, because half of what I'm saying I've forgotten about already anyway, and I got to go back and look at it each time I go mess with the thing. So honestly, sometimes I can't believe how much stuff changes and how it's easy to forget about it. By the way, one of the other things about Get Pitch that can be good, the presentation guy right down there, is you can set the theme. The people viewing this can set themes and so on and change the view of it. I don't know. Right now, I'm kind of iffy on it because I see some aspects of it that are a little bit of a pain to use than I expected to be. So let's do this. Let's go look at examples of real Docker files that are out there just to see the kind of stuff goes in them. We'll pick one that's Postgres. Pop that guy up right here. Now, what we've done is we've gone to Docker Hub, or what used to be called Docker Hub. We're looking at the image repository for Postgres. Notice, here tag, you probably can't see squat. There, let's do that. So there are versions of the Postgres that are sitting out there. This link goes back to the Docker file that produced it. Let's do this just for the fun of it and see what real in the sense of more complicated Docker files actually look like. And let's go through them piece by piece. So, I haven't seen that syntax in a while. I've forgotten that you can give them some info up front. So what this is saying, if you can see it, this is saying from the Debian distribution, the Jesse tag, we're going to start with that. Then we're going to run, while building this image, this group add command. We're saying we're going to add Postgres as a group, and then we're going to add a Postgres user. We're going to set the user ID of that user, and it's going to be called the Postgres user. The group Postgres user Postgres. So in other words, if you were building Postgres by hand and running it, these would be the steps that you would go to. So what you're doing is the way that you build and run stuff right now, your own utilities, you would do something analogous in a Docker file to say produce that. Next, notice we're going to set an environment variable. So we're setting GoSU version, whatever that is, to 1.7. So this is saying within the environment of this image, when it runs as a container, there will be an environment variable called GoSU version 1.7, equal to 1.7. Next, this is saying we're going to do a variety of things in here. We're going to update the distribution. We're going to install wget, if you can see my cursor, and then we're going to clean up stuff afterwards. This is an example of efficiency, meaning when you start building images and you've got commands in your Docker file that do a variety of things, some of those things are adding stuff to your image you probably don't need later on. For the user to actually run this, they don't need the repo fully populated, for example, meaning it's a specialized image that you want it to be it's desirable to be as small as you can possibly make it. So in some cases, you'll see people doing cleanup type functions where they get rid of stuff out of this image because there's no reason for anybody to be doing it. If they want, they could run the image, exec a shell into it, and update it if they wanted to, for example, but there's no reason that it has to be ready to go out of the box. And I know that's confusing. I'm not saying in very clear fashion, but the point being is that it's an example of reducing stuff inside of images that are not actually needed. Next, this is saying, next I want to do a wget GoSU. Again, I don't even know what that is. Get it from here, print some stuff, then go get the key file associated with it, or the provenance associated with it, or verification, or whatever it's called. Export that as an environment variable, run GPG. What you're seeing are examples or an example of a real Docker file going out and doing things that are required to create a Postgres image, an image that can run Postgres. And I know this is more stuff than you might be interested in, but it's things to consider. If you're making images of your own that you're going to distribute, those images are going to contain a variety of configured things. This is an example of the kind of configurations that you're going to end up having to do so that those images can run entirely standalone later on, or effectively standalone. Let's see some of the other stuff in here. So we're setting into the environment. Going to exit on any kind of error in the shell. If there's a problem, the shell will give up and the build will fail. Let's go further. We're setting environment variables again. We're going to echo something to the user. No, we're going to echo this out into a file, so you'll be able to go look at that file afterwards. where that will get used by something else in the image. So we're updating the package list here. Now we're doing an update again because something subsequently needs to be added to it. This is, we're adding the Postgres related repository stuff to this image. That's what's happening. Now it's saying go install Postgres and the SQL, the SQL client associated with it. We're going to set stuff inside there. So what you're seeing are general shell functions. If you were going to write a bash shell script that installed Postgres in a directory on your system, you'd be doing a lot of exactly this same thing. Let's go a little bit further. Run command. Notice there's a succession of run commands in here. Each one of these run commands is actually going to add a layer to this image, by the way, and when you see that happen, it can make quite a bit more sense. Set some environment variables. Now here's the first copy command. Copy from the host file system, meaning when you do a Docker build, it's expecting that there's something called Docker entry point.sh shell script. We're going to copy that into user local bin. Then we're going to create a link, again, in the image file system that's being produced. Notice, next we're saying when somebody runs this image, by default, we're going to run that script that we just copied into the file system. Okay. Lastly, we're going to expose a common Postgres port so that when the engine runs this image and somebody says expose, map the ports, basically the dash uppercase P, for example, the engine will say, ah, he's talking about port 5432. And lastly, we're going to run the Postgres command when somebody runs this. That's a long description of a lot of stuff, but this is what making your own Docker file will tend to look like for more sophisticated or larger tool sets that are going on. Let's look at, sorry, yep.
When somebody runs that Postgres command that you had there, does it actually just run Postgres or does it do the build?
It runs Postgres. The build, so when you do a Docker, if you were to pull this repository, you would see in it a Docker file. In that directory, if you said docker build dot, it would go through all of these steps to create an image that has a number of layers in it that do all of this. So at runtime, when somebody says Docker run the image that you just built, what it's actually going to do is only pretty much this last thing. Run this script because the image is already prepared. All these steps sitting up here are part of the build process.
Right.
So remember when I said a while ago about it packed the CLI, the Docker CLI, packages up everything and sends it off to an engine and the engine goes through all the work. This is an example of all the packaging that gets done. All of this stuff that's being referred to in here is being sent to that engine and the associated files, meaning the current directory on down, being sent to the engine. It's going through the build process. It's creating a new image composed of a number of layers that get put into the image cache, and then that's what gets run when you do a Docker run command. I know that's yep.
If you're ever gonna kickstart or install a new system, this is sort of like that. This configures something that you need to run later. This is like the installation commands the system.
Right.
Put this file there, put this thing there. So when you need to run it and you boot your computer, they are available.
So there's another question? Yeah. Yep. Oh, let's see you first. Yep. Yep.
All this stuff gets executed and creates the Docker file containing everything necessary to run Postgres in that environment. But this stuff does not wind up in the file. Is that correct?
Okay, what you're looking at is a Docker file. This isn't creating a Docker file. What you're looking at is a Docker file. This guy right here for Postgres 9.6, and it describes what's required to run Postgres as a container.
But this gets executed one time.
Docker.
It doesn't get executed every time.
Correct, right. This gets executed
This is
only when
the
somebody
run
does a
command.
build.
This is not the run command. This is the installation
Yep.
command.
Right.
Where does the physical image exist?
It exists where the engine that this got sent to is running, it exists in its cache, its image cache, with a unique identifier, a UUID associated with it. Okay.
It's a question there.
Yep.
Where is the Docker file located?
It's located, in the simplest case, it's in your shell session. When you run a shell and you do a Docker build command, it's expecting to find a Docker file in your current directory. So now the Docker file could actually be in a CM repository. It could be in a continuous integration system that Jenkins is checking out and built. Sorry?
If I get, and then Docker file, where is it live on my machine? Wherever you say.
The Docker file is,
Something, I just got the hello world thing, and like, I don't know where that file is, I'd like to see it, but I don't know where it is, I didn't tell him to save it.
correct. Okay, that hello world that you just ran, you did Docker run hello world, right? That pulled the image called hello world, put it in your image cache, and that's what's running. It's not the Docker file. The Docker file is considered the Docker file to be the equivalent of a source file.
Okay.
So it's used as an artifact to build an image. The image is what gets run. So the Docker file is simply very analogous to just source code, software source code.
Have that file.
Correct. You won't have that. And that's why sometimes that metadata is useful so that somebody can refer back to it. So now, in answer to your question, let's do exactly that. This was one of the things I wanted to show because it gives you an appreciation of what those images are. Let's do this. So for example, oh, it's not that there. So I'm up here in ECS or AWS right now. Let's do this. Let's do every time I do this, I do it wrong, so I have to think about it for a while. Now, I'm going to Docker save the image that I just pulled to a tarball. So that's going to take the image that's sitting in your image cache. Did it actually do it? Oh, look at that. It actually did it. So I typed it right for a change. Now, is somebody else saying I got a problem?
No, it's me.
Oh, okay.
Just responding.
All right.
Sorry.
So what I just did was the image that got pulled from Docker Hub, potentially by default Docker Hub, called Hello World, got put in the image cache on my machine, and then it got run as a container. It did the Hello World output, but the image is still sitting in my cache. So to see that image, I'm going to say, there. That's what actually went into the Hello World. So just for the heck of it, let's do this. Okay, I'm going to extract. So the Hello World image is nothing but a tarball with some extra metadata sitting inside of it. Inside that tarball are potentially other tarballs. So what you're looking at right now is the actual image. Let's take a look at the one of the metadata files there. Now, so inside that image is a file called the image name.json. It has in it quite a bit of what was in the original Docker file. So when I said that you don't have the Docker file, you don't have the exact actual Docker file, but you do have the metadata that was in, some of the metadata that was inside it actually in the image itself. So if you look around in there, you can see these things. I don't think you can reconstruct the Docker file, although I'm not certain about that actually. I don't know if you could reproduce the Docker file from only this, but this will tell you a whole lot about it.
No, we can't. In all your run commands, how would you reverse those?
That won't, yeah, it won't reverse that, but I mean the image itself, the Docker file that was done. So this is an example of some of the stuff that's sitting in there now. The next thing, let's go into the actual image layers. Let's make it. Let's do this. Yeah. I know a lot of this is confusing.
So I don't see where you are. You're in your temp directory, your home directory.
Yeah, it's going a little fast.
Yeah.
Can you see the bottom line that he's typing?
Yeah.
Okay.
So what I did was, if you do the same thing, do Docker save -o a.tar and the image, the hello world image, it will create a tarball that has that image in it. And then all I did was make a directory, go into that directory and explode that tarball just to keep it from overwriting itself in the same directory. That's all. So all I did was just navigate down inside of it. So here I am at the lowest level, and this is the actual thing that does the hello world. This is an executable that was inside that image. Let's see, I thought I did a file. Didn't I do a file? Oh, there it is. There. Notice. It's a statically linked binary, just for fun. There. So what I just did was I ran the hello world binary that was inside the image. So this goes back to the point I was saying earlier. In the hello world Docker file, which would have been a good idea to have up here, I guess, there's probably something that says entry point, run hello. I just did it by hand, actually. So I exploded the tarball that comprised the image, went down inside of it, and actually ran the binary that will get runs when you do a Docker run in that image. I know that's confusing. It is. It's until you do it a few times, it can be confusing too, but it's worthwhile doing this to get an understanding of what images actually are. So, and an example, probably a good example would have been to do build hello world. So maybe we'll do that. Let's see if we can get to that point. So let me see where we're at. So this was the Postgres container. Let's go back to, let's say, a distribution. If we wanted to make a CentOS distribution, just did exactly the same thing. Go to Docker Hub. Here's what a CentOS distribution looks like. Now, the reason I wanted to include this is this. This is the Docker file for CentOS 7. It's different than what we saw for Postgres. Notice, from scratch, every Docker file has to start with the from. The first executable thing that the first keyword that it can operate on has to be from. That from tells it what distribution image or base image to start with. If you don't want a base image, let's say you had a Docker file, you wanted to make an image that had nothing but data in it. You can do that by saying from scratch. Scratch simply means nothing. Start with null, the equivalent of null anyway. So, but notice the next command. Add, we're saying copy something from the host when I do this build. But what we're adding is a tarball to it. That's the actual CentOS distribution. In other words, we're not building CentOS as part of the Docker build process. We're taking an artifact that was produced previously, that the output was saved to a tarball, a .j tarball, whatever the super compressed is, and then we're simply adding it to that image. Okay? The point I'm trying to make here is that Docker files are not always a collection of a whole bunch of little files. They can actually be one big old file that has in it a whole bunch of other stuff. So notice what this is saying. So we're saying add the CentOS distribution to it. Put some labels in to indicate what this here thing is, when was it built, etc. And lastly, if somebody runs this image without any arguments, jump into a shell. Okay, so let's, for the heck of it, let's do this. What?
Do you have that topple?
Oh, sorry. Let's do this. Let's see what happens. I'm going to explain it in a moment. So I'm doing a Docker run of something analogous to that Docker, the image produced by that Docker file that was just here. And I'll show you why we're doing this in a second. There. So what I just did was that CentOS Docker file, I ran it or something pretty close to it with no arguments, and it dropped me into the shell within it. Now, look around in here. Right? There's a reason, well, there's a whole bunch of reasons I did this, but when Docker sees an add or copy and it's a archive file, it actually will explode that archive for you. In other words, I didn't have to go in and say, take that big old CentOS distribution, extract it, and create it. The Docker engine did that for me as part of the build process. Okay? So, and what you're looking at right now is exactly that. In other words, you're looking at the equivalent. If you were running CentOS on your laptop, for example, you should be seeing exactly these same files. But we're not running the CentOS kernel. We're sitting on top of the Zen hypervisor, or whatever the right term is, on another distribution running CentOS. So for example, I'm on Ubuntu and I'm running CentOS. You view it kind of like that, but it's not like I'm running the operating system on top of it. So a little bit more.
Is that a full CentOS then?
Yes.
Okay.
Including that graphics?
Well, okay.
It's headless, yeah.
I mean, so the whole idea of containerizing things is to make it as small as possible. Right? The whole idea of how this came around was the density that you can run on a server is a lot bigger if you just install the bits you need, no more, right? When you install a whole OS, even when I do a minimal, it's like 600-700 packages. And that's without a GUI. It's usually 1,500 or more if I need the GUI and I want all my tools. And I don't use a tenth of that for my web server. So these images tend to start from an extremely small base, and there's a lot of energy put in to make them even smaller. I mean, sub 100 megs, one image. And even less. But that also means there's a lot of stuff that you think you take for granted are not there. A lot of the commands that you tend to run, like IP, is not there. It's just not needed. Like, I mean, those commands are all being given to you from the outside. So you don't need to configure your IP addresses. You don't need to be scanning things. So when you go in and you do your BAS, you can do an LS, maybe a PS. You're going to all of a sudden find a lot of commands you are used to don't show up. Be the one that should be that. Now, if you want an image where you need those commands, you say, build my image, add these commands, and now you have your own image very easily, and it's just that little Delta image you're going to install on top of it. So it's easily done, but we don't want them in the base images. We only want the base stuff. So there's like glibc and very basic stuff. They even now have images where there's not even a systemd or anything else because you're not putting anything. So we're trying to make them as small as possible, but you're going to get very confused when you're in there because most of your commands are not there. Yeah, that is small.
Yes, so the hello world that where you ran a little while ago that you just did, this is the Docker file for that hello world. So the point I'm trying to make of this is this. Let's do this for fun. Because we're here, we got nothing better to do today because apparently we don't have lives. All right, just for the heck of it. So now, here's what I just did. I did a clone of the GitHub repo for Hello World. Okay. I went down into that directory. Here's what you're going to see. Do this. We're going to do this just for the heck of it. We're going to say Docker. I can't do it that. I got to do it a different way. Let's see. Let's see if this works. I haven't tried this. So I wanted to see what it did. Ah, there we go. Look at that. Son of a gun. All right. Let me explain what I just did. I don't know anything about the Hello World repo other than that I wanted to make that Docker image for it. So what I did was I cloned it. I went into the Hello World directory inside of it. This guy. Inside there, there's that Docker file we were just looking at a moment ago. All it said is start with nothing, but copy in something called hello, which is a pre-built executable. There he is right there. Copy that into the image. And then when somebody runs a container from this image, just run that command.
Try to do 5 minutes.
Yep.
Hello.
That'll say it's elf executable.
Statically linked, right?
Right. Yep.
So you have no dependencies,
There,
libraries,
exactly.
anything. There's no OS really in there.
Yep. See, that's the key thing to note. It's one of the things that people like about Go. If you go back to years ago where we were building C executables, you had to have glibc in, load library set with a bunch of other libraries or all kinds of dependencies and so on, which meant if you were going to make with that, you would have to have those things available, or you'd have to make what's called a statically linked executable. So it was one big executable that had the whole shebang in it. In this case, this is simply saying, take that hello source, produce a static binary that's Go, that all it has is this in it, and it's an 1800 byte file. This guy right here is the actual hello executable, and you can run the thing by hand. So again, the points I was trying to make about Docker files was, forget where we were now. This guy, this might, no, I bet this is it. Nope. There we go. Point I was trying to make is that there are different ways to produce stuff doing Docker build. And what I wanted to do was show more than just the simplest possible Docker build. I wanted to see examples of the kind of things that are in there. Let's keep going on a ways. So the way that you can make your images, one, you can do a build. Another way that you can do it is this. You can run an image as a container, put stuff in there, data files, do an update, install tools, whatever it is that you want. And then you can actually say, take that container and save it as a brand new image. And then that is a usable image. So you can customize that image for use. I actually do this all the time. In fact, if I have a Postgres is probably the most common example of that, where I run a Postgres container, configure the schema the way that I want it to, save it to a new image, and now I got a ready to go Postgres that's set for whatever kind of regression testing or whatever that I'm doing on the thing, rather than doing anything more complicated than that. So my point being, there's at least a couple of ways to build images. One is with a build command. Another is simply run a container that has what you want in it, add whatever extra stuff you need, and then say Docker commit, and it will save that to a brand new image. And now the next time you run that image, it's exactly the way that you had it configured a moment ago.
So,
yep.
So it's a little bit like a snapshot.
Yes, absolutely.
The system, it doesn't save the data, it just saves all the configuration.
It saves the state of that container at that moment. So yes,
okay.
it saves the whole shebang. Yep.
So if you're able to build your final image one step after the other, then you just don't need to know how to create the Docker file.
You don't, we're correct. You don't have to have a Docker file, right? You can make it from an image, customize it. The reason you might do that is if you have to run a, and my example is Postgres, if you have to run a database and it needs to have some particular schema in it, instead of you manually doing that every single time, create that container in the state that you want it to be, and then save it or commit it to the new image. And the next time you say run that image, you're just bringing it back to life again, exactly as it was at the moment you did the commit.
That's cool.
Okay, so it's a way to save time, effort, etc. You probably wouldn't distribute that. I mean, it's not you can commit that image and then push that up to Docker Hub or your own repository and say, here's my ready to go image. But typically you would start with a Docker file with just stuff you're distributing, but you don't have to. Let's go a little bit further because I have some examples, I think, of this. Tags. I wanted to throw this in there because when you push stuff up to Docker Hub, you might have a tool called Migrate Utility, but it's a good idea to have a version number associated, version 1, version 2, version 3, so that somebody can run the version that they want. So when you do push commands, which is how you take an image that has been built and you push it up to a repository somewhere, you most likely would including tags associated with that. Let's keep going through this. I know I'm putting a whole bunch. There's an example. I want to build using the Docker file in my current directory, and I want to call it my Alpine with a version the latest on top of it. Okay. Now, this is me saying I want to run the image that I've got on my. I want to run something called my Alpine. The engine is going to check the image cache to see, do I already have something called my Alpine? If it does, it's going to use that. If it doesn't, it'll go out to Docker Hub or whoever it's configured to talk to and look for something called my Alpine. If it finds it, pull it. And if it doesn't, it'll complain and say, I don't know what you're talking about. So again, make something called my Alpine. run something called MyAlpine. So, what I said a moment ago, let's say you are running, it's probably a little smaller than I thought it was there. Run an Alpine distribution, run the shell in an Alpine distribution, call it test 1. In another window, we're going to say, take the container called test 1 and commit it to a new image with that name. The reason this name is here is this is saying the repository that I want to store this in and the image name I want to store it to. So in other words, up in Docker Hub, there's probably a Doug Top in test 1. I would be willing to bet. I most likely did that when I was doing this. So I know I'm compressing a whole lot of information into this stuff, but I wanted to do more than just the simplest possible, here's how you build stuff. So if you're going to Dockerize an application, the Perl script, that lenticular, I always go back to, wherever it be. I don't know where it is. Let's go back. Let's get it back up there again. Chug, chug, chug. This is an example of something I wrote a long time ago that all there was this Perl script to Dockerize it. All I did was this, or all you would do if you're going to Dockerize any application first. What does it need? In this case of the Perl script, it needed Perl. So I got to start with a Perl distribution or Perl base image. Okay. Now the script's got to go in the image itself. So where's that script? And this was in the repo, the Perl script. What else do I need for this to work? Meaning, do I need any outside files? Because this operates completely standalone when you run it somewhere else. What is it that you want to run when somebody runs a container from this image, meaning the name of it? And lastly, what kind of arguments has somebody got to have to run it? So going back again, let's look at the Docker file. There's a question, what's it coming from? I'm saying from Alpine. I want to copy the Perl script that's in the current directory into the /temp directory in this image. I want to update Alpine, and then I want to add Perl. And lastly, when somebody runs it, this is what I want to run. So that's the answer to the questions that are needed. So if you go back and look in the repo, all that's in there is the Perl script and the Docker file. That's all that's actually needed to do it. So it answers each of these questions get answered, and then I have the README says what arguments to run it with. Let's go a little bit further. Once you start building images, they're on your local machine. They're on the machine, whatever your CLI is configured to talk to, probably your local machine. And you can run them forever until you remove them. And if you remove them, then you got to build them again. Once you have an image, you want somebody else to use it, you're going to do what's called a push of that image to somewhere else. That somewhere else could be Docker Hub. It could be a range of places. So I got some examples of it. You hear the term registry every now and then. That simply says, here's a place that knows about the image I created, the metadata associated with it, and that registry has a repository. It actually has a physical file system somewhere to keep the image that are being pushed. Examples of them are going to be Docker Hub. That's the one you hear about most. You're also going to hear Red Hat Container Catalog. That's something that there's a whole lot of neat stuff going into. I was looking at just yesterday, in fact. So has official Red Hat stuff in it as well. It's going to also have certified stuff from other vendors at some point, if it doesn't already. Another example of a registry will be ECR, SAWS registry. It could be a place to keep images. DTR is what's called Docker Trusted Registry. This is a product of the Docker company. They have their own registry repository that I'm not sure if it was the first one or what, but that's what you can get from them if you want to run your own. Or lastly, you can create images, put them out and export them or save them to a tarball and give that tarball to somebody else and they can import it right in. So for example, you could create an image, give it to a tarball and hand it to somebody else and say, here's my image. And they would never have to connect to Docker Hub or any other registry repository. So it'd be the lowest level of way of sharing images. Or you could give them a Docker file and they could build the thing themselves. Right, let's keep going. Still got a little ways to go through here. The way that you would typically put an image that you built somewhere else, you would go through these steps. First, you would log into the remote registry or the registry, whatever it's remote or not. You would tag your image using the name that you're about to send this image to. For example, Doug Toppin / whatever that was. And then lastly, you would push that. That simply means go to My Image Cache and connect to the remote repository and push, give it this image. Let's keep going. Now, here's something else to be aware of. Images have multiple layers in them. Remember, we saw that CentOS earlier. We saw the Postgres, etc. There's a whole bunch of stuff sitting inside there. Let's say after you've created this image, that somebody says, "Ooh, I just found a bug or some malicious code in the tar command or whatever it is, something that's inside that image." In other words, you have an image now that has bits inside of it that have a malicious or a bug intent in them. You need to do something about that, most likely, because now you've got a vulnerability sitting in there. So you would need to go and update that image to have a fixed version, or rebuild it to have to be a new image with an updated version of whatever's fixed in there. So my whole point being is this: when you look at these layers that are sitting inside here, what we did just a moment ago, and well, Hello World is probably not the best example of that since it's pretty small. But if you go back to this guy, this layer has the Hello executable in it. What if there's a bug in the Hello executable? In other words, something that you see showing up a lot nowadays are image repositories have scanning services where they will go through, look at all the images inside of them, and compare the contents of those to a vulnerability database, a CVE, to say, I know that this version, that version 1.0 of Hello has a bug in it, and you got that in this image. So this would be something you would typically not worry about yourself on your own machine. I'm simply talking about this because images have executables inside it, may have executables inside it, and those executables may have bugs or malicious codes in them. Enterprises have to worry about that kind of stuff. So they have to have something that goes through and tells them, we're running this on 1,000 nodes and there's a vulnerability inside it. We got to do something about it. So that's a term that you'll hear coming up fairly often nowadays, or image scanning. So when image scanning says this image has got a problem, and you've got that image, how are you going to get that image deployed, updated and fixed in your system? You'll hear the term content trust used fairly often. Who made this image? Has this image been changed by somebody else since they made it in the first place? That becomes particularly of interest. So once again, you will probably never worry about this on your own machine. But if you were distributing images to someone else, you would start thinking about, I need to sign these so that nobody else can replace this image with something other than me. So you hear content trust. Notary is a service or a client server type thing that does image signing. When somebody goes to run your image, if they have trust turned on so that they can only run trusted images, their system will go check with a notary server and says, yes, this is the right image. We're going to allow it to be done. Nobody else is repeated it. So lastly, some of the links for doing this kind of stuff. Here's just some examples. I know I talked about a whole bunch of stuff, and when I first started thinking about this presentation, I was thinking, I would just do a Docker build. You can't just do a Docker build. You really do have to address the various things that show up in Docker files. You have to think about images. You have to have some recognition. So it's not like you're going to walk away and be able to do stuff. But vocabulary-wise, when you see these terms and names, they should mean a little bit more to you. So what kind of questions do you have that I have done a poor job explaining? I know there's no lack. Yep.
So I'm kind of new to Docker, so I just wanted an appreciation. So when you get to a Postgres Docker build,
yep.
So how is that different from Postgres install?
It's not. Other than Postgres install is installing it on my machine. The Docker build is installing it in an image that somebody else can run somewhere else without installing Postgres. All they do is run the image. Did that answer your question?
So.
But the steps are pretty much going to be the same, actually. So Postgres install, if you're going to do it locally, it's going to be pretty close to those steps of that Docker file.
And where is the advantage? So why wouldn't if somebody is using Postgres, would they not want to install the machine?
Absolutely. I try not to install stuff. Here's an example. The reason is this. This week I need Postgres, but then I'm not going to need it again for 6 months. Or I need Postgres 9.1 for one system I'm working on, and then Postgres 8.2 for another one. And I don't want to install both of them. Run them both as containers, and I can have whatever I want on my machine and accessible without me having to physically install or maintain it. So the point I was trying to make is that whenever you locally install something, you're responsible now for updating it, etc. If you're running it as a container, all you want is, I want Postgres X running on my machine with this endpoint exposed for some period of time, and then I don't care about it ever again. So the advantage is if you can run stuff as containers, it will be less maintenance on your machine, most likely. Yeah, no, that's true. I mean, it will probably be less maintenance. But an example, I use 3 different versions of Java over a period of a year. That is by far and away the best example of it. So I can install all 3 JDKs, JREs, all MJ stuff, and then I can set environment variables to point to Java home, or and whatever all those other things that Java and its big old ecosystem comes around with it on my machine, and then I can switch them at different times depending on what I'm doing. Or I could simply say I want to run a container I want to run a Java build, for that matter, using Java 8. And as a container, it runs, and I don't care where it physically is or nothing.
What I'm looking at is, when I used to manage a lot of boxes, the biggest questions we always have to do is, if I want to run this program and that program, hey, but this has these dependencies, this one has that dependency, and finding out how to maintain something where everything was nice to one another, and you did an update of one of them and didn't destroy the other one. That's a very tricky thing to do when you want to run a lot of stuff on the same box. Containers, particularly the container images, what you're building, removes that completely from your view, right? Because now each of those verticals are completely isolated.
Yep.
So I can now say to the guy, and this is why I'm doing this, I can say to the guy who maintains the old version over here, this is your box, you make sure that that's up to date with security, and I can tell the other guy over here that this is your box, and you maintain security. The fact that they're running on the same box in the end, they don't see, and they don't care. That's the strength of maintaining the build scripts and stuff like that, because now I don't have to be that complete expert in the whole box and understanding network stacks and file systems and all. I can just be my Java expert or whatever else I'm using and make sure that that is configured correctly without concerning myself about anything else running on that system. Or, as we've been told, it might be running on a different box tomorrow. I don't care. My container is the same regardless of what machine it's running on. Even if that machine may have been 10 core boxes or 64 cores or terabytes of memory, I'm just seeing my little world all the time, and that's it.
One note, by the way, I just remembered something I didn't say and I meant to. And that was, remember the expose command that said I want to have this port available? So run nginx and tell it to expose whatever port it is that it has. So if you go look at the nginx distribution, it will say it needs port 80. So when I ran nginx, I said docker run nginx -p nginx, something like that. That says take the port nginx needs and expose it as whatever host port you want. So in other words, up in EC2 right now, I've got this host port attached to this container port. I'll show you. I know I shortened something that I wanted to say a little more clear. Let's do this. Yep, there's that nginx that's running right there on that host. Okay, but notice, I said I need this port exposed. When I ran it, this is what it looked like. This is how I ran it. Docker run as a daemon, meaning detached in the background. Expose whatever ports it needs, Nginx. And that's what it did. It mapped them. It exposed port 80, attached it to this. I could, however, have said run Nginx and attach it to the host port 80, to whatever port it needs, to the host port 80. I know I'm jumping around right now, but my whole point being that this is where you start have to thinking about it. If you're building images that are going to be run as containers that present network services, you have to start thinking about how ports are mapped. So in other words, there's only one port 80 on the host. I could have run this in a way that says expose this on the host port 80, or I could say just expose whatever port you want, but now I have to configure a load balancer to know how to get to this specific port. So I know that's a big subject. So anyway, any other questions? Yeah.
Like the Hello World example, said you can have a tarball which actually has the executable in it.
Yep. Mm-hmm.
That's only good for that container. I mean, it's built for that operating system.
Oh, no. There's no operating system.
Well,
That's the whole
it's-
point.
It's like a 64-bit compiled executable.
That's the only dependency you have is your kernel. That's it.
Yep. It's dependent on the kernel, right? Yep. See, by running this as a container, you don't have to think about how it's built. It's up to the engine to what's actually called containerd. It's up to it to run the thing on top of whatever virtualization it has. So in other words, anybody with Docker installed can run that hello world, and they'll run exactly the same executable, same image, and thus executable.
The executable itself isn't valid for business.
Yeah, you could not take that x86 ELF binary and run it on Windows. But what I just did by hand, it would not work on Windows, but on Docker on Windows it would.
Vulnerabilities that are associated with that Docker. I mean, it's a word.
Yes. Oh, they're associated with the image. Vulnerabilities, you said, right? If there were vulnerabilities in Hello World, they would be in the image, not in the host that's running on it.
But is that any different than whatever you put on your VM? Like if you're running Hello World and that, it will still be vulnerable in that box.
Yeah, I keep waiting until it be out, but I've had folks like it's none of the Docker is not virtual.
But imagine this. So say you have Hello World and another program running on it. And Hello World is vulnerable to a backdoor or whatever. On the same box, could be a VM or whatever. Would that other program running on that same box would now be part of that, be vulnerable because there's a backdoor. This prevents that from happening.
Let's do this. And I know you're kind of expecting to come in and do a bunch of Docker build commands. Let's do this. Let's pick something like, I can't think of anything that's not like it can take 30 minutes to build. I was going to clone it and do a build, Docker build. I'm drawing a blank right now. Let's just say Perl. So, right here, if you wanted to build, all you would do, clone the repo on a host. I'm not going to actually do it because I think it will take eternity. Let's pick a particular release. Let's go to whatever this is. So what I just did, what I'm about to do, is I'm going to say Docker build using the Docker file that's in this current directory. I don't know what's going to happen, but you're saying exactly what you would do. That is how you do build Docker images. So notice what it's doing is pulling all the layers that comprise what it needs to create that Perl image. Of which, if you look at the Docker file, you can actually see the different things that it's having to get to go through this. All right, I know this is not a trivial subject, but it's a stepping stone type thing, meaning running Docker stuff, that's one phase. The next thing is building your own. The way you build your own is you create a Docker file that answers those 5 questions. What Is it based on what's got to go in it? How do I run it? Those sorts of things. So if you can answer these questions, you can build you can make Docker files. Let's go back to whatever this was. Let's see, back to here. Okay. If you can answer these questions, you can make a Docker file that will distribute your stuff. Alrighty. Sorry, that was a long-winded type presentation. And ask questions anytime you want. If you can see the word Docker file in a repo, you could probably build that thing. That's what it boils down to. If you got Docker installed.
You can do it.
Yes. Alrighty. All right. I'm going to close the thing down.
All right. As usual.
Oh yeah. Let's switch back to the camera so we can.
Thank Doug for his answering all the questions and his in-depth research and sharing his information. Thank you to Peter for the space here, and Susie again for feeding us and hydrating us for the week. Xavier took off. He's going to be talking next month, like I said, on DNS. Susie connected with someone who may be able to talk about Go in the future. So that's a possibility too. And again, remember we do have the Slack team for anybody who wants to continue or get assistance during the month. So
Yes.
I've been able to use it. Doug's on. It's basically Doug, me, John Kennedy, and there are one or two other people that pop on there occasionally. But yes.
So the website is dead. Is that right?
So it should be fixed. Well, I'm sorry. I asked, and I'll ping John again. So there was something happened. It went down, and it was sort of broken, and then it totally disappeared. And I asked John to point it to a meetup page for now. So I will ping him again today.
Yeah, it just goes to pages isn't working.
Okay, is it still like that today?
Yeah, it's a Drupal message.
Okay. Yeah, so I will ping John again. I pinged him on Monday. He said he'd take care of it, and then I didn't bother following up. So I'll follow up with John to see if it happens, just for him to update the DNS or transfer it over to me, whatever it was. I think I have .org or .com. One of them does belong to me, and I think I updated mine to point to the new update. But
Yeah, I'll go to .com.
I guess we might want to put mailing list information, all that stuff in Meetup. I mean, Meetup has its own mailing list, so I want to make sure we don't get people confused if they're all in there and what they inside.
yeah, I mean, I don't know what's going to happen. I have a feeling the website's going to be dead because John's just way too busy, I think, unless someone wants to take it over.
Well, the problem was John has been asking for volunteers for a long time, and no one has stood up to be able to say, hey, I want to learn or I want to do something. It's an excellent opportunity if you want to figure out how things work.
Yeah, and basically every 5 to 10 years until it gets redone, whoever takes it over does it. I don't really all it needs to do is say where the mailing list is, where the Slack channel is now, and where the meetup page is. So it's relatively straightforward. So anybody who wants to do it, feel free to let me know. So, all righty.
Right, close that.
Thank you, everybody.